In this video, we're going to talk about finding zeros of quadratics. Zeros are nothing more, nothing less than x-intercepts, or where a graph crosses, or where a parabola crosses the x-axis. Now, the x-intercepts, where it crosses the x-axis, is a particular point where you have an x value, but the y value is 0. It's not above the x-axis, not below the x-axis. The y-coordinate is exactly 0. For that reason, we simply set our equations, our functions, equal to 0. Now, I'm going to do some examples both from ax squared plus bx plus c form and from vertex form, because how you approach these can vary. Now, we'll start with vertex form, and I have 0 equals 2 times x minus 1 squared minus 1. We're setting equal to 0, and so it's just an equation. Add 1 to both sides, and I have 1 equals 2 times x minus 1 squared. Divide both sides, divide both sides by 2, and you get 1/2 is equal to, those simplify out, x minus 1 squared. And then I square root both sides to get rid of that squared. And what you have to understand here is that the squared and the square root do in fact cancel out. You have x minus 1. But we have to remember, in the context of an equation, when you take a square root, it gives me plus or minus. It's a positive version and a negative version. Now, I'm not going to worry too much about simplifying this square root in this moment. You can clean it up, change the presentation, but it is effectively that right there. It's not a particularly pretty number, so I'm just going to leave it as it is for the moment. To finish this up, we simply add 1 to both sides, and we end up with x is equal to 1 plus or minus the square root of 1/2. So that means that one of the x-intercepts is at 1 plus the square root of 1/2, and the other is at 1 minus the square root of 1/2. Those are the two places on the x-axis where this parabola will cross, the x-axis. So these are pretty straightforward. These being vertex form are pretty straightforward. They're all going to take this basic shape more or less. So this is not as interesting. What's a little more interesting is what you do when you have one in ax squared plus bx plus c, because there's a few different ways you can go about this. So ultimately, the first thing you can check is this factorable? And in this case, this one is factorable. And so if it's factorable, you should always factor it. Factoring is a nice, neat method. And this factors to be 2x plus 1 and x minus 2, I believe. Let me double check. Let me just double check and do it old-fashioned way. So being that I have 2x right here, one of those has got to be 2x, and one of those has got to be x. This one I'm getting 2x squared. And let's see here. I have one of these has got to be minus 2, and one of these has got to be plus 1. Yeah, I think that's right. 2x plus 1 times x minus 2. That checks out. Now, finding the zeros simply means setting equal to 0, finding the x-intercepts. So I have 0 equals 2x plus 1 times x minus 2. The zero product rule says if either of these factors is equal to 0, then that whole thing is 0. So I can set each of these factors equal to 0. So 2x plus 1 equals 0, and x minus 2 equals 0. The first one is slightly more work, although neither of them are bad. 2x equals negative 1. Divide both sides by 2, you end up with x equals negative 1/2. This one is pretty simple and straightforward. Add 2 to both sides, and you get x equals 2. Those are the two zeros, the two x-intercepts for this particular parabola. Now, as you're well aware, things are not always factorable. And so if we have something like this, f of x equals x squared plus 4x minus 7. I need two numbers that multiply together to be negative 7 and add together to be 4, and the answer is there's not any nice, neat numbers that do that. And so what do you do if you can't factor? So one strategy is to actually do something kind of like what vertex form is. We can complete the square. And so if I have 0 equals x squared plus 4x minus 7, we need to complete the square, as in change this right here into a perfect square trinomial that factors real nice. And so the first part I would do is I would get this 7 out of the way. I would say plus 7 to both sides. And that leads me to 7 is equal to x squared plus 4x plus the perfect number. And we'll figure out what that is in a second. If you want a refresher on the strategy completing the square, you might look back at the videos on circles because we completed the square there. So the perfect number, so if you remember from that circle videos, the perfect number will always be the b term over 2, b divided by 2, and that value squared. So a is 1, b is 4, so that's 4 over 2 squared. 4 divided by 2 is 2, 2 squared is 4. So the perfect number in this case is 4. Now if I add 4 to the right-hand side, I also have to add 4 to the left-hand side. This now, x squared plus 4x plus 4 is a perfect square trinomial, and it can factor to be x plus 2 squared. The left-hand side is kind of just collateral damage. It just is what it is. It wasn't our main focus. Whatever happened to it, and it happens to be 11. Now we can finish this off by taking the square root of both sides, and that brings me to x plus 2, and that leaves me with plus or minus the square root of 11. That's an irrational number, super ugly, it's just the square root of 11. We finish this problem by subtracting 2 from both sides, and x equals negative 2 plus or minus the square root of 11. So the two places, the two x-intercepts, the two places where this parabola crosses the x-axis, one of them would be negative 2 plus the square root of 11, and the other one would be negative 2 minus the square root of 11. So we can complete the square to find the zeros, but there's also a little more generic way. And ultimately, this generic way is very similar to what we just did. It is a completing the square, but it's completing the square of the general form of ax squared plus bx plus c. If you do completing the square on this, and I'm not going to do it in the video because it's a long process and it's not going to make you any smarter, but if we do completing the square to this, what comes out the other side is the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac. If you want to see me do it, I'm happy to schedule time and actually write out how we go from this, completing the square, to getting the quadratic formula. Yeah, hit me up if you want to see that. But what this is the ability, it's a formula. You can literally take your a, b, and c values from your quadratic, from this quadratic right here, and simply plug those values into the quadratic formula, and it will give you these same two answers. So let's look at that problem with the quadratic formula. So just to bring it down and rewrite it, we got f of x equals x squared plus 4x minus 7. Now, in this, we have to look for our a, our b, and our c. Now, in this case, a is 1. That's 1 times that. So we have a equals 1, we have b equals 4, and we have c equals negative 7. Please make sure that you pay attention to the operation in front of that constant, that c term over there, because it tells you if it's positive or negative. So that's definitely negative 7. Now when I do this, I always want to make sure that I have the quadratic formula written immediately above where I'm writing, so that I don't have to be looking back. I want it written right there. And since it's written right there already, we're going to roll with this. So I have x equals negative b. I highly, highly recommend you always substitute into parentheses. It'll help you minimize your mistakes with signs. It's really easy to screw up signs. And I have plus or minus the square root of b squared. Oops, I'm actually filling in now. B squared, so that's 4 squared minus 4 times a, and a is 1, times c, which is negative 7. All right. So all of that over 2 times a, so that's 2 times 1. Now if I go and start cleaning this up, I'm going to take this little piece here out to the side because it's a lot of work to show. So I got 4 squared is 16, and I'm just going to do order of operations here, times 1 times negative 7. So 16 minus 4 times 1 times negative 7. 4 times 1 is 4. 4 times negative 7 is negative 28. So I have 16 minus negative 28, which those two will add together to be, what is that, 44? 44. So let's see here. As I go to clean this up, I have x equals negative 4 plus or minus the square root of 44 all over 2. Now, when you look at this, it may not look like what we had right here, negative 2 plus or minus the square root of 11. But when we clean it up, it will. So the square root of 44, if I split this into two radicals, I can split this into the square root of 4 times the square root of 11, which gives me 2 square root of 11. So I have, let me change back colors. I have x equals negative 4 plus or minus 2 times the square root of 11. So now we see that square root of 11. It looks a little more like it's supposed to, over 2. Now, when you have this whole fraction, all that stuff on top divided by 2, it basically means divide both terms by 2. So divide this by 2 and then divide this by 2. So negative 4 divided by 2 is negative 2. We got plus or minus. 2 square root of 11 divided by 2 is just square root of 11. And it has become exactly what we got when we completed the square right here. So quadratic formula, we can complete the square by hand, which is what we did right here, complete the square. You can complete the square by using the quadratic formula, which is the work we did right here. Now, a couple things I want to say about this. One, quadratic formula always works 100% of the time. And some people find comfort in that, and if you find comfort in that, that's awesome. It's okay to do that. What I will tell you, though, is that it's very computation heavy, and it's very abstract. It's not like if you're looking at this, you're like, oh, I see where I made a mistake. It's hard to find your mistakes in this. Your execution must be perfect. It must be flawless. There's no room for error. I think that completing the square by hand is a little more intuitive. I think it makes sense better to people. And so your options are factor if it's factorable. By all means, factor it. If not, you're going to complete the square, either by traditionally completing the square or by using the quadratic formula. And I don't care which you do the one that works for you. I teach an in-person version of this class, and a lot of my students really seem to prefer doing it, completing the square by hand. You do what works for you. Get really good at one of those strategies.